Welcome to section 2.1. This is part 2 of relations and functions. And just to start you off with, here is the much requested math joke. How does a cow do addition? With a calculator. Ha ha. To begin our discussion on relations and functions, we need to talk about some terminology first. Let's start with a function rule. A function rule is an equation that represents an output value in terms of the input value. Or you can say that it represents the y-coordinate in terms of the x-coordinate. Now, without already knowing it, we have done a lot of work already with function rules. A common example is a linear function. When we take a linear function and rewrite it in slope-intercept form, that is a function rule. So an example would look like this. Y equals 3x plus 2. Because I took my output value, which is y, and I wrote it in terms of my input, which is an x. Okay? Now, function notation is a little different. It is taking, what function notation does is basically it replaces y with f of x. And you should probably know how we read that. You need to read, or f of x is read as f of x. Okay, so let's say, going back to our example of the function rule, y equals 3x plus 2, I can rewrite that in function notation. I simply take out the y and I replace it with f of x equals 3x plus 2. So that means that that function rule and then this example, those are equivalent. Now, your independent and your dependent variables we've already talked about. Your independent variable is your x. That is your input. And then, of course, your dependent would be your y value. And that, of course, is your output. So when you are evaluating functions, all you're simply doing is you're substituting a number in place of the input. So let's do an example. Using our function rule, f of x equals 3x plus 2, let's evaluate it for when x equals 2. What that means is if x is my input, or 2 is my input, and I want to know what is my output going to be. So think of this as like a little machine. I'm going to throw in 2, and for x, that means that on the right-hand side, everywhere I see an x, I replace it with 2. Well, 3 times 2 is 6, plus 2 is 8. So, when my input is 2, my output becomes 8. Or I can think of that as an ordered pair, 2, 8. Okay, let's try an example. Number 5. We want to write y equals negative 4x plus 1 in function notation. And then we're going to find the outputs for 3 different input values. Alright, so if you're going to go back to function notation, all you simply do is you replace the y with f of x. So that's going to look like f of x equals negative 4x plus 1. That's in function notation. All right, and now I want to know if my input value is, we're going to start with negative 2. If I'm going to input negative 2 into my function, then I want to replace every x that I see with negative 2. And I have negative 4 times negative 2 is 8. 8 plus 1 is 9. So I could say that f of negative 2 equals 9. Or you can write that as an ordered pair. Since your x value is negative 2, your y value is your output, and that is your 9. All right. Another example. Let's do this with f of 0. All right. When you do function notations, this left-hand side tells you what your input is. So it's saying I'm inputting 0 into my function. So then I have negative 4 times 0 plus 1. And I have 0 then plus 1, which is 1. So I could simply say that when my input is 0, my output is 1. Or again, think of that as an ordered pair, 1, 0. Okay, now the third example, I'm going to leave it for you. And you need to tell me, when you come back to class, what is my output going to be when my input is 5? So I want you to continue the same work and then show me your answer. Number 6, determine if the graph is a function. If so, evaluate it for f of negative 2, f of 0, and f of positive 2. Okay, so to determine if the graph is a function, we're going to go back a day, and that is simply, if you have a graph and you want to know if that graph is a function, all you need to do is a vertical line test. Can I draw a vertical line anywhere on my graph? How many times does my vertical line touch my graph? 1 time, so it's a function. We're going to say yes, it's a function. Okay, now here, we can still evaluate a function even though we don't have a function rule. If I have a graph and I want to know what is f of negative 2, well, that negative 2 represents my x-coordinate. So at negative 2 right here, when x is negative 2, what is my y value? And you should see that it is 4. So f of negative 2 equals 4. In other words, oops, let me erase that part. In other words, the point negative 2, 4 is on the graph. Another example, what is my output when x is 0? So think about it as if x is 0, what is my y-coordinate? So I go to where x is 0, and I go to where it's on the graph when x is 0. And you should see then that it hits 3. So I have the point 0, 3. Okay, I want you to tell me, or I want you to find out what is f of 2. So when x equals 2, what value do you have for y? All right. Hopefully you had enough time and you see that it is 1. So it's a 0.2, 1. Okay, here's another example. Number 7. A carnival charges a $5 entrance fee and a $2 per ride. A. Write a function to represent the total cost after taking a certain number of rides. So let's say you don't ride anything. Well, how much do you pay to still get in the carnival? $5. And then if you do ride $1, let's say you ride one ride, then you would have now paid $7. So every time you do a ride, you're going to add an additional $2 cost. So your function rule is going to look like this. Let's say I want to do C, and you can use F, doesn't matter. I want to say the cost of doing the rides. So I'm going to put C of R. But you could use the same old F of X if you wanted. You're always going to have that $5 entrance fee. But then you have to add to that $2 for every ride you're on. Now when you go to write a function, you need to notice that your r, the variable that we are assigning in the function rule, needs to be the same on the right hand side. I'm using r. Okay, b, what is the value of the function when I input 12? And then what does it represent? So let's do the first part. First of all, I just want to know what is c of 12. Alright, so I am evaluating my function. I have 5 plus 2 times 12. And that's going to be 24 plus 5. So I have 29. Now, what does that r represent in our function? If you're saying that r represented the number of rides you were on, you would be correct. So what this represents is if I ride 12 rides, my total cost for the carnival will be $29. Whoops, is $29. Okay, now for example 8, what I want you to do is save that. We're going to discuss that the next day in class. But if you would like to go ahead and try it, please feel free to do so.